This lesson covers function arithmetic and resulting domains. We'll begin by finding the sum of two functions. Let's find f plus g of x using f of x equals 2x minus 1 and g of x equals 2x squared plus 1. F plus g of x is defined to be f of x plus g of x. In this particular problem, f of x plus g of x is going to be equal to 2x minus 1 plus 2x squared plus 1. We will simplify and end up with 2x squared plus 2x. So f plus g of x is equal to 2x squared plus 2x. What about the domain of the sum of two functions? The domain of f plus g is the intersection of the domain of f and the domain of g. Here f of x equals 2x minus 1 has a domain of all real numbers, as well as g of x, which is defined to be 2x squared plus 1. The intersection of two domains containing all real numbers is also a domain containing all real numbers, which would be the domain of f plus g. Next, let's look at the difference of two functions and try to find the difference f minus g of 2 if the value exists using f of x equals 2 over x minus 1 and g of x equals 3 over x minus 2. So f minus g of 2 is going to be equal to f of 2 minus g of 2. F of 2 would be 2 over 2 minus 1. G of 2 would be 3 over 2 minus 2. And it looks like we have a problem here. 2 minus 2 is equal to 0, and we can't have a 0 in the denominator and come up with any value here. So it looks like the value does not exist. So the value here does not exist. But before we go on, let's look at what the domain of our function is. So what would be the domain of f minus g of x here? The domain of f minus g is the intersection of the domain of f and the domain of g, similar to f plus g. The domain of f of x here, it would be all real numbers except 1. The domain of g of x would be all real numbers except 2. The intersection of those domains, which would be the domain of f minus g, would be all real numbers except for 1 and except for 2. Let's next find the product of two functions. I want to find f times g of 3 if the value exists using f of x equals the square root of 7 minus x and g of x equals x plus 2. F plus g of 3 is going to be equal to f of 3 times g of 3. F of 3 would be the square root of 7 minus 3. G of 3 would be equal to 3 plus 2. That simplifies to the square root of 4 times 5. And the square root of 4 is equal to 2. 2 times 5 would give us a result of 10. What would be the domain of f times g of x here? Well, the domain of f times g is the intersection of the domain of f and the domain of g. Here, the domain of f of x, we would need to have 7 minus x be greater than or equal to 0, which means negative x would be greater than or equal to negative 7, and that would result in x being less than or equal to 7. So the domain of f of x would be all real numbers less than or equal to 7. The domain of g of x would be all real numbers. The intersection of those two domains, which would be our domain of f times g, would be all real numbers less than or equal to 7. Okay, well, let's move on to finding the quotient of two functions. This time I'll find g over f of x, g divided by f of x, using f of x equals 2x minus 1 and g of x equals 2x squared plus 1. g over f of x is defined to be g of x over f of x. In this case, that would be 2x squared plus 1 divided by 2x minus 1. This can't be simplified any further, so I can say that g over f of x is equal to 2x squared plus 1 divided by 2x minus 1. Let's finish off here by looking at the domain. The domain of g over f is the intersection of the domain of f and the domain of g, provided f of x is not equal to 0. So let's look at the domain of f of x. Looks like that would be all real numbers. The domain of g of x is all real numbers. The intersection of those two domains is all real numbers, but we also need to make sure that f of x is not equal to 0. So we need to be sure that 2x minus 1 does not equal 0. This would happen if 2x would be equal to 1, or if x would be equal to 1/2. Okay, so our domain of g over f is going to be all real numbers with the exclusion of 1/2. Finally, here's a problem that you can try on your own. Find f minus g of 3 if the value exists using f of x equals 2 over x minus 1 and g of x equals 3 over x minus 2.